Dear students, I have taken your one class for macroeconomics, that is classical job employment in class. Today, this is my second class. I opt to go to mathematical economics to your paper 4. I choose to teach you module 2, optimization in case of one independent variable y equal to function of x. As you know, x is independent variable and y is dependent variable. Any number put for x will change the value of y. So y is depending on x, so y is dependent variable and x is independent variable. And the important thing is that optimization. What does optimization mean? Optimization is just like a term used as change we use in economics. Change means rise or fall. Source optimization is maximization or maximum or minimum. The process of finding out maximum and minimum value of a function is called optimization. Maximum or minimum, if we draw a diagram like this, we find several points here A, B, C, D, E as maximum. Every point is a local maximum and we find B is the global maximum among them as it is the higher. But whenever we calculate maximum value, we calculate always the local maximum. That means at point A or B or C like that. So also in case of minimum we find several points of minimum like F, G, H, I, so that. And every point is the local minimum, G is global maximum minimum, but we calculate always local minimum. Now we go for, we know y equal to function of x and we can find derivatives. dy by dx is called derivative of y with respect to derivative of x. What does it mean? It means that change in y for a small change in x. It is called first order derivative. When we calculate derivative of the first order derivative, that means dy by dx, again we find out the derivative of first order derivative. We call it second order derivative. D square y by dx square is the symbol. It is not multiplied. It is a symbol of second order derivative. Like that, we can find third order derivative when we calculate derivative of second order. That is symbolized by dqy by dx cube. Third order derivative, like that. We will find dny by dxn. This is nth order derivative. It is called nth order derivative. We need second order derivative and first order derivative for optimization. For example, we can take an example of a problem 2. Solution for higher order derivatives. For example, y equal to x cube minus 7x square plus 5x minus 9. We can find dy by dx first order derivative. We can symbolize it as f dash x. like this. It is what happens, the power rule is applied, 3x square minus 14x plus 5. Second order derivative is the derivative of first order, as we know earlier. It can be symbolized as f dash x. It can be calculated from first order derivative with power rule 6x minus 14. Again we can find third order derivative like that, f dash x. It is only 6 d fourth y by dx fourth, symbolized as f iv x is 0. And in this problem we cannot continue further, as the value is now 0. Any number of derivative after that we will find that the value will be 0. This is the process of finding out this is the higher order derivatives. Now we will go to analyze optimization. Optimization can be calculated by two methods. First one is first order derivative method without using second order derivative. This is first order derivative, we can find out the value, and then the second order derivative method. Now we will switch over to first order derivative method. That means we take only dy by dx equal to 0 and find the value of this. I draw 3 diagrams for this, or one diagram now to clear our notion, our idea. This is the maximum, this is the minimum, and this is point of inflection. It is very important to know inflection because it will lead to convex and concave or convexity of the function. First using first order derivative, what we find that the curve is rising here. So dy by dx is greater than 0 here, or positive slope. We can say, we know that dy derivative is the slope of the function. Then we find after this point of maximum, what happens, the function is falling. So dy by dx is less than 0 or negative slope. Whenever we find a function is rising than falling, we conclude that this is the maximum, the function gives the maximum value in first order derivative. Similarly, for minimum, what we find that the function is falling now, then rising. So the derivative, first order derivative is less than 0, that means the negative slope, and then dy by dx is greater than 0, that means positive slope. So whenever a function is falling than rising, we find that it is a minimum value. But look at this. This point is inflection because we find the function is falling up to that point, and after that point it is also falling. So what we conclude that positive to negative maximum, negative to positive minimum, but negative to negative we find the point of inflection. We can summarize like this: maximum, minimum, and inflection. How? Positive to negative, negative to positive, and negative to positive, negative to negative, or positive to positive. This is the condition of finding maximum, minimum or optimum value of a function using first order derivative test. In economics, what we find is that very interesting thing we will find that the total utility function is maximum here. How it is maximum? We find that it is negative to positive to negative. And we know that the total utility. Derivative of total utility curve is marginal utility. So marginal utility is positive. We know that so long as marginal utility is positive, this is value 0. Positive and then negative. Marginal utility is positive, it is falling, but it is positive. We find that this function is rising, and after that 0 it is negative. Marginal utility is positive here, so derivative is positive, first order derivative. du by dx is negative positive, and after that mu is negative. So we find that this is the maximum point of total utility when the marginal utility is 0. We know it from economic theory. However, we use the first order derivative method in economics to know the how total utility is maximum, is giving maximum value. Like that, we will also explain the minimum cases. Now, coming to an example. Coming to an example of first order derivative test. Let a problem is given y equal to 18 minus 4, 18 minus 4x plus x square. First order derivative gives the value minus 4 plus 2x equal to 0. Then 2x equal to 4, x equal to 2. So we find that the function whether maximum or minimum, the x value is 2. Now taking x as 1 and x equal to 3. 1 is before 2, 1 is after 2. We will find whether it is positive, negative or negative to positive and conclude that it is maximum or minimum or inflection. Now putting the value in first order derivative, minus 4 plus 2 into x1, what we find is minus 2. Putting x equal to 1, x equal to 3, minus 4 plus 2 into 3 gives plus 2. So we find that the function negative then positive at x value equal to 2. X value equal to 2. Before I take 1, after take I will take 3. These 1 and 3 are arbitrary numbers nearer to x. Any number you can take, but 1 and 3 I am taking is the neighborhood value. What I find that value is minus 2. That means the function is falling and then it is rising. So what we find that the function is minimum according to first order derivative test. Likewise, we can take many examples. Dear students, you should follow my book written as the Simplified Approach to Mathematical Economics to Kalyani Publisher, and you will find every sorts of different type of questions for your derivative tests, first order derivative test. Now we will go to second order derivative test. Second order derivative test. Second order derivative test for optimization. Second order derivative test for optimization. Second order derivative test has dy by dx we have to find, and d square y by dx square we also find. What happens that it is a minimum value, minimum point. At x the function is minimum. That means first order derivative slope is 0 here. First order derivative equal to 0 as it is 180 degree. So the value of tan theta at 180 we know that it is 0. Likewise we can draw a value or a curve like as maximum. At x value it is a maximum because if the value the slope gives 180 degree slope and tan 180 degree equal to 0. Then dy by dx equal to 0. Now, why this point is minimum? Because all points above the point gives maximum value. Likewise, the point is maximum because all the points other than this point is falling or going down. So, second order derivative we find here is less than 0, and the second order derivative in case of minimum is greater than 0. This is the minimum, this is the maximum condition. So first order derivative we find that it is always equal to 0 and it gives value of x, but the second order derivative will define us the function, whether the function is maximum or minimum. Now, for our better understanding, we should have a table for this. We should have a table for this. Y equal to function of x, first order derivative, or it is called first order necessary condition. Second order derivative we call it second order sufficient condition, and this is the figure. Now if we find the minimum, first order derivative equal to 0. Second order derivative will be greater than 0 because at the minimum point all the points are above the minimum point, and the figure will be like this. Look at this. Any point other than this point is rising. That is why the second order derivative is greater than 0. Maximum dy by dx equal to 0, d square y by dx square less than 0, because from this figure what we will find that any value other than this point is going down, so it is less than 0. What happens to inflection? Inflection point is the point where first order derivative equal to 0, second order derivative is also equal to 0, and if we draw the diagram like this, this is total product curve. This is the point of inflection here. This is the point of inflection. Point of inflection, what does inflection mean? The point where a curve changes its direction or curvature is called a point of inflection. Look at this. The point, the curve which is rising may go on this way, and falling point may go in this way. But what we find that the curve changes direction at this point. So we call it as a point of inflection. Taking these three conditions, you will go to my book and refer. This thing is very clearly, lucidly explained in my book with a table. There is also another condition for rising and falling. We will discuss it later on, and we will go for maximum minimum inflection point and the application of this in economics. Now we will go for a problem taking in our example of first order derivative 18 minus 4x plus x square, and what we found here their function was minimum. We should check it by taking second order derivative also. The first order derivative, when we find it, we will find this as minus 4 plus 2x equal to 0, 2x equal to 4, x equal to 2. In second order derivative, there is no need for taking any number arbitrarily as we took in the first order derivative as 1 and 3. It is not necessary here. We will go for second order derivative here. D square y by dx square equal to 2 only. Plus 2, that means. Plus 2 means greater than 0. What our condition or optimization condition table told? The first order derivative equal to 0 and second derivative greater than 0 means the function is minimum. We can take another example and we find the value of x and test it for the first order and second order derivative. Just like this. Another example we may take like that. Y equal to minus x cube plus 9 by 2 x square minus 6x plus 6. This is the example given in the book. Now, taking first order derivative dy by dx, what we will find is that minus 3x square plus 9 by 2 into 2x minus 6 equal to 0. We will cut 2 and 2 here. So what we find is the 9x. So we will have a factorization here to find the value of x. 6 into 3 equal to 18. 9 should be divided, or 9 should be taken as two numbers, so that the addition of the two numbers will be 9 and multiplication of the two numbers is 18. Look at this. Minus 3x square plus 3x plus 6x. 3x plus 6x equal to 9x minus 6 equal to 0. Taking minus 3x common, x minus 1 plus 6 x minus 1 equal to 0. X minus 1 again taking common, minus 3x plus 6 equal to 0, x equal to minus 1 and or we may take or x equal to 2. So, from first order derivative we find the value of x 1 and 2. Taking second order derivative for this problem, second order derivative will be minus 6x plus 9. Now putting the value of x here, x equal to minus 1, x equal to 2. Look at this. In second order derivative, if we find there is a x, we have to put the value of x from the first order derivative. If there is no x and only a absolute number or a number, we can judge whether it is plus or minus and we will conclude that it is maximum or minimum. Look at this. X equal to minus 1 means d square y by dx square equal to minus 6 plus equal to plus 3 greater than 0. That means minimum 2. D square y by dx square equal to minus 12 plus 9 equal to minus 3 less than 0. It is maximum. Likewise, we can find the value of x by taking first order derivative equal to 0 and putting the value of x in the second order derivative. Then we find the different types of values of x or the functions to be maximum or minimum. Now, have known the conditions of maximum minimum and some examples on it, how to find the function maximum or minimum, we will go for economic applications. Economic application of maximum and minimum. The first application is market equilibrium. Second is SC and MC relation. Third one is MP and MP relation. We will judge three things from optimization in case of one independent variable, market equilibrium, essence relation, AP-MP relation. Now we will switch over to market equilibrium. Students, as the video is finding lengthy, we will stop here and we will continue in this next class the economic application of the optimization in case of independent variable. And we have economic application left, and after that the conditions of convexity concavity and its application. And your second unit will be completed on derivative. We have another part in the second unit, that is integration, and I have completed it in your class. Thank you. In next class we will continue economic application, optimization in case of one independent variable. Thank you all. Dear students, this class I am taking will not be sufficient to you. Please go through my book. This is the book I have written and published in Kalyani publisher as per CBCS model syllabus. A Simplified Approach to Mathematical Economics to Semester 2, and it is published by Kalyani publisher. I have another book also, the Mathematical Economics 1, which is read in your first semester, and I am going to complete another book on econometrics, which will be your 5th unit course, econometrics. It is on the verge of completion. Have patience and read that book also. I wrote every book thoroughly, vividly, as my knowledge is concerned and the experience I gained from the class taken in my college and from the complaints from my students. That is why I think this book will be more valuable, more useful, more lucrative to you for this purpose. Thank you.